Hi, my name is Scott Baird. In the next few minutes, I'm going to show you how to build your models faster with higher quality using model objects. Model objects are pre-built, self-contained, smart model segments that can be plugged into your models in seconds and save you hours of modeling time. The same concept that manufacturers have used to build products can be used to assemble simulation models. Just as a PC manufacturer wouldn't think of building a power supply each and every time they needed one, you shouldn't have to build every aspect from scratch for your simulation models. Many elements are common to all models. We have taken some of these common elements and turned them into model objects that can be simply copied and pasted into your model. All you have to do is copy, paste, connect what goes into the model object, and where the output from the model object goes when it's done. It's just that simple. Let's walk through an example. If you needed to be able to represent an arrival with an on-time, late, or no-show scenario, you could go to the Solutions Cafe and select the Arrivals category. Then go through the Arrival model objects and select the model object needed. When you install the model package, you'll notice that the model objects are designed to run so that you can see how they operate. There's an explanation of what it accomplishes and detailed step-by-step instructions on how to implement the model object. In most cases, there's an explanation of how the model object works. Use the Control-A keyboard combination to select all pieces of the model object that you'll need. Use the Control-C keyboard combination to copy the model object. Go to your model, center the layout where you want to paste the model object. Use the Control-V keyboard combination to paste the model object. Connect your arrivals to the model object and connect the output from the model object to the remainder of your model. In this model object, instructions are given that explain that scenarios are used to adjust the percentage of people that are late, by how much they are late, and the percentage of people that don't show. Go to the scenario parameters to make the desired changes. In this example, the percentage late is 12%. The distribution that explains how late a customer will be is defined by E4, an exponential distribution with a mean of 4. And the percentage of people that don't show is 6%. That's all there is to it. The model object is implemented. Further in this model, there is a need to show the change in success rates every time an entity goes back through the same activity. No matter what type of business you're in, you'll experience something similar, an inspection operation with varying chances of success based on the number of times an entity has visited that activity. Again, go back to the Solutions Cafe, go to the Inspection category, and select Vary Pass-Fail percentages each time through the loop. The instructions for this inspection model object say that you're to connect the pass route to the remainder of your model. Connect the fail route to where things go if they are rejected. Open up the action logic of the decision and change the percentage of the first pass, second pass, and etc. The complex logic to handle this variable pass-fail percentages is now implemented. Finally, in this model object, we hold samples to be sent to the outside lab until 4:30 in the afternoon. Back to the Solutions Cafe and select the Flow Control category. Select the model hold until a specific time and day. Draw a route into the model object. Draw routing from the model object to the remainder of your model. Notice that this model object has two parts. The first part connects with your model, and the second part is a controlling device for the model. It's called a trigger. The instructions explain that you should change the arrivals to occur each time you want the model object to release entities. In this case, a daily pattern arrival was chosen with the start and end time occurring at 4:30 p.m. This means that one entity will arrive at precisely 4:30 every Monday until the end of the simulation. You could add other arrivals to account for other release times, or you could even change the type of arrival to match your requirements. When an entity arrives, action in the trigger activity causes a floodgate to open in the model. All the entities that were waiting at the storage model object will be released. If you implement more than one of these in your model, they will act completely independent of each other without any adjustments needed by you. In this model, you've handled three complex situations with relative ease. In a nutshell, here are the benefits from using model objects. First, you'll save time. Logic found in these model objects will take you a long time if you have to develop and test it yourself. On the other hand, you can use these model objects in less than a minute. Second, you'll have a higher quality model. These model objects have already been used in production simulations around the globe. They always work correctly, they will work in a variety of situations, and they will work with other model objects. Third, you'll look smarter because model objects are smart. If attributes or variables are needed, they're added to the proper dialog automatically. If you use the model object more than once, it knows how to interact with other versions of itself and completely rewrites the logic in the clone model object automatically, so you don't have to worry about the interactions. Well, that's it for our tutorial on model objects. Take a look around and become familiar with all the model objects. They'll save you a ton of time. And as always, thanks for joining me for this short tutorial on model objects.